Well, thank you folks for joining us for the latest in our 2024 summer heat pump webinar series. Um, like to thank you for taking the time to join us today. Um, and would also love to thank our sponsors. You can see them down at the bottom of our screen. This could not be made possible without their support. So thank you so much to Core, Energy Smart Colorado, the Beneficial Electrification League of Colorado, Holy Cross Energy, Clear, Tri-State, and High Country Conservation Center. Just a couple of housekeeping items to go over before we get started here. Um, like I said before, this webinar is being recorded, so it will be available to view on our YouTube page within a few days. Um, so anybody who couldn't join us live can certainly watch that recording at a later time. If you have any questions at all during the presentation, please go ahead and enter those in the Q&A function, that Q&A chat box down at the bottom of your screen. If you're having any sort of technical difficulties, you can send us a chat and we can try to troubleshoot them for you as well. But all questions should go in that Q&A and we will answer them at the end of the presentation. This is our schedule. So we had 4 previous heat pump webinars covering all sorts of different systems for both existing and new homes. Again, those are all available to view on our YouTube page. So if you're interested in learning about any other types of heat pump systems, please feel free to check out our YouTube page. I will send a link here in the chat, but we'll also follow up with an email to everybody who registered with a link to this recording as well as the others and some information about local incentives as well as a copy of the slide deck that Dave will be going through today. So today's presentation is all about ducted heat pumps in existing homes. And again, thank you again to our sponsors listed there. Really value your support. So thanks again for helping make this happen. This is showing the community organizations out there available in your area that are running the Energy Smart Colorado program in different areas on the Western Slope. So or up in rural Colorado. So if you have questions about any sort of incentives available in your area for heat pumps, or you just want to learn more about Energy Smart Colorado and what they can offer, please contact any of those organizations in your area and they can get you the information that you need. And last but certainly not least from me, I'd like to introduce our presenter today, David Petroy. David has well over 15 years of experience in a range of renewable energy and sustainability business roles. He was the excuse me. He was the founder and president of Blue Valley Energy, which is a successful ground source heat pump engineering, design, and installation company in Boulder, with over 200 installations throughout Colorado. During the early 2000s, he led technical sales of solar and energy power systems for residential and small commercial businesses at RMS Electric. And then at Golden Aluminum, which is one of the largest single-site industrial power users in Colorado, David was responsible for leading adoption and implementation of a facility-wide energy monitoring system and upgrades to reduce energy consumption on large industrial production processes. Most recently, he did consulting work with Xcel Energy and helps customers understand their energy use. And in 2017, he launched NTS Energy, a consulting company focused on providing advanced HVAC and solar solutions to homeowners and small commercial companies, while also promoting the transition to the new energy economy in Colorado. David holds a master's of science in geophysics from Washington University in St. Louis and a bachelor's in zoology from SUNY Oswego. So, David, I won't keep you any longer here. Go ahead and take it away.
All right. Thank you, Diego. Welcome, everyone. I think about 25 slides. It'll take probably about a half hour to go through this. The idea is to give you all an idea for existing homes. You've got a furnace and a duct system, or you're thinking of a new home. Also, some of this applies, though we have other talks that are more targeted to that. Give you a complete idea about this. So let's get started. We have several topics to go through. And you'll get this slide deck, so some of them I'll just skip through and read. I think the main reason we're even here is heat pumps have dramatically improved. So about the about 2005, around the world, people were looking at why are heat pumps just used in mild climates? There's no reason we can't use them in any kind of climate. So there's a big effort on cold climate heat pumps. And there was a lot of efforts on defrosting, how to make them work really well in cold climates, and for about 5 years. And there was also work mainly started in Japan and Europe, but it really built on it in North American momentum. And the cool thing about heat pumps is there's a lot of equipment inside of them that they can improve, like the compressors, the alloys, the walls, how they design the fan blades. So there's just constantly, and even to this day, we're just constantly improving the insides of these units, and it results in a lot of improvements. The first one is capacity. So this colored diagram here, this is the outdoor temperature from 0 to 70. And this green line is a house. Well, just say it's about a 2,000 square foot house. And this would be the amount of heat required to heat as it gets colder, this green line. Now, in the past, say in the year 2000, heat pumps would be this thin blue line. This is how much heat they could put out. And as it got colder, it would drop off dramatically. And then over the last decade, or about 15 years, every iteration, they keep improving, improving, improving. And now the best heat pumps are cold climate, high efficiency. And notice this orange line. Basically, they can produce almost the same amount of heat from 50 degrees to 0. Then they'll tail off a little bit, but they still can produce heat. Several of the best cold climate systems can go all the way to minus 13. This one here is called Tier 1 high efficiency heat pumps. And notice they're able to produce heat. It drops some, not near as much as this. And notice about 20 degrees it crosses over. And there's still this wedge up here, or a bigger wedge, that we need to have some auxiliary heating to work in tandem with the heat pump. And we'll talk quite a bit. So that's one. They can keep their capacity heat when it's cold. Two is efficiency. And this is from about 2012 to 22. There's really not been a huge jump the last couple of years. This is called HSPF2, which stands for Heating Season Performance Factor, second generation measurements. And the higher the number, which is the blue, the better. And this is the percent improvement. And notice right now, a lot of these HSPF, it's right in around here, a lot of the systems. This is the absolute best system. So think of it as they're about 30% more efficient than they were. In fact, that translates directly into saving money. Basically, 30% less money to use them now. So that's why they're a very effective system at this. So basically, we have these efficiency improvements. We had higher capacities. We can heat below 0. And the other one I didn't talk really detail about is improved defrosting. So when it's around freezing and you get icing, the systems can ice up. Now they can reverse melt the ice, or when it's really cold. So this was also a nice this was a necessary improvement to make them work in all climates. So today we're going to be really focused. We're going to focus on cold climate heat pump systems options for homes with ducted heating systems. And it's quite a simple options here. You've got, so assuming for the moment that you've got a furnace that heats, And what you can do, and we'll talk about, it's called a dual fuel system. It's a heat pump with supplemental furnace. So you might keep your furnace or replace it. And we'll talk about when and why. And you put a unit outside that looks like an air conditioner. And it's just going to have inside, it has a reversing valve so it can heat or cool. And over here, what you would do is you would just replace the furnace with called an air handler, which is going to be nearly the same size and shape. It just doesn't, instead of having a gas burner at the bottom, it would have some electric strip heating coils as a supplement. And again, you've got this outside unit. So really, these are the two choices we're talking about today. So why would you want to switch over to a heat pump? Well, if you want cooling, there's no use getting an AC because really AC just is like driving a one-way car. You might as well have a system that can do a lot of your heating and your cooling. These ones also with less energy use. You are helping reduce outdoor emissions from your home heating system. They do. You don't really see it, but there's emissions, NOx, etc. It reduces your heating bill if you're heating with a propane furnace. Against natural gas, it's pretty much a little bit plus or minus, but it gives you some resiliency against future price spikes, and you reduce GHG emissions. So there's many advantages to it. So why is it so efficient? There's videos and stuff about how heat pumps work, but really what you think about a heat pump isn't creating heat, it's just moving heat. And it's pretty easy system to move heat. and it's so you think of it as taking heat from a big volume of outside air, concentrates the heat, moves it inside. So the efficiency term is called COP, and that's called coefficient of performance. It says if I put 1 unit of energy in, how many units of heat energy do I get out? And a furnace, a 95% furnace is 95 efficiency, so it's 0.95. Electric heat is 1, that's resistant. A heat pump, COP, is around 3. This varies during the season. When it's the spring and the fall and mild and the outdoor air temperature is, say, 50, 40 degrees, it's higher than maybe 4, can move a lot of heat. When it gets really cold in the winter, it might get down to about 2, 2.1, 2.2. It's harder. It needs more energy, but over the season. So it really, if you look at this is only 33% of the energy. So the energy-wise is very much lower. Electric heating or propane, you save quite a bit of money because the cost for electric energy versus propane is pretty much par. So you're going to save a lot of. So with versus natural gas, as people know, if you look at natural gas prices over the last few years, last 10 years, they go up and down and up and down. But generally, because heat pumps, that big jump in efficiency, now they're basically, I'd say, on par with. On par meaning some years the heat pump saves a bit. Other years it's a little bit more. It's back and forth. But in general, over time, it's going to be pretty much the same. The other thing is you do have, we'll talk about a little bit of flexibility in which fuel you use. But in the spring and the fall, heat pumps cost much less to heat. So to give you an idea, this lower picture on the lower right, I think a lot of folks, when they first start looking at this, feel that in Colorado, we use most of our energy heating when it's really cold. That's not true. The bottom is minus 20 degrees outdoor to 70. And this is the percent of energy use. And notice about 1/3 is when it's above freezing. And then the big bulk is between, say, 15 and 35 degrees. And then below 15 degrees, and this is up in Eagle, it's about 18%. So when it's really cold, it's not a huge percentage. It's just because of the number of hours. So I don't need to go. I'll just highlight a couple of things on this. You're going to get the deck if you want to. You can go and study it. But the other thing is, this is annual heating costs. And so this would be a propane furnace, and this is an all electric heat pump, and this is uh, heat pump with a furnace. And notice there's a lot of savings. The thing I want to point out here is this is the system these are, I say, median system costs, and there's some very nice rebates that comes through. And in the end, your cost to put in a furnace with an air conditioner versus the heat pump systems are a bit lower. And then you're also going to be saving this money every year. So it's a good deal. You pay a little bit less for the overall system, and and you get all these benefits. Even if you decide you didn't want cooling and this number went down, let's say that number went down to 10,000. So you're still saving a couple thousand a year. So in a few years you would get your money back. As I said, natural gas is a little different story. This is natural gas. So this is the cost with heat pump and air handler. So it costs a little bit more per year. Here with the heat pump and called the dual fuel, you save a little bit over the pure gas. And one thing to point out for those of you who, are thinking about these other benefits in terms of air pollution, et cetera, is that, you reduce your natural gas use. The other thing is cold climate heat pumps are typically more efficient, the ones we put in, than commonly installed AC. So you would actually save a bit on cooling. And again, this is like initial costs. So the initial costs are a little bit less with these benefits versus gas and AC. So it's becoming a pretty good strategy financially also. This is to try to give you an idea for those of you who are focused and concerned about GHG emissions. This is in 2002, and these are this is the amount of emissions annual. This is a car. So to give you an idea, these are on the order of car. These are heat pump systems. Here's furnace systems, and here's hybrid systems. And notice that the furnace might be it's in the middle here, but now as the grid, and especially Holy Cross, Excel, our utilities in Colorado continue to make improvements, and believe it or not, they are on schedule in a lot of ways. Notice that the heat pump systems by 2027 are going to be putting out lower emissions. And if you look at this over a 15-year period, so you're going to buy your system and it's going to last 15 or 20 years. As we continue to improve how we generate electricity, you're going to end up saving a lot more. Your emissions are going to go down a lot. And I like this big color pie chart because it sort of gives you an idea of how you use energy. Look at space heating, space cooling is next. So we're looking at these big two ones, water heating, and a car is somewhat on the order of this. The only thing that's a bit more than that is flying. So how do you think about, okay, I want to do this. What should I do? How do I make sure I'm going to get a good system? So we're going to talk about all these factors and how we get a good system. I think this is less and less, but there's still some stuff out there about, heat pumps don't work well when it's really cold, and the heating costs are more than expected. And usually it is with most things, it's a mistake or something not done right. It wasn't really a good heat pump that wasn't matched well. It wasn't one of those ones that holds their capacity. The system might have been too small, or it wasn't installed right or set up right. Like the way it's controlled, it was using too much as a backup. So before we talk in more detail, let me describe. This is sizing terminology, so you really know. So BTUs per hour is really how much heat do I need to heat my house, and those are in the order of thousands. And then furnace sizing terminology, can be in BTUs per hour. That's normally the way furnace. So you'll say I have a 60,000 BTU furnace, and 80,000, 100,000. Heat pumps, people talk about tons. 1 ton is 12,000 BTUs. So typically, for most homes, you're in the 3 to 4, 5 ton range. Smaller apartments or condos, et cetera, might be in here. Now, the way to know that when you look at like if you're getting quotes and people, you're seeing model numbers, there's usually these numbers in the middle of these long model numbers, 030, 036, 042, 48, and that corresponds to these BTUs or these tons. So those are just some terminology. So you're looking at your house, you have this furnace, you might have an air conditioner, or you might be wanting to upgrade your air, your air conditioner died and you want to know what to do. So you've got two strategies: dual fuel or all electric. This is the chart I talked about before. And there's a couple strategies. One is with the dual fuel, you have a heat pump that goes down to about 15, 20 degrees, and you have your furnace. The one where it's all electric, you got a heat pump, and then down to about 10, there's some combo back and forth with the heat pump and the electric, and then the electric back there. I like looking at this chart. This is an eagle. This is your temperature bands, and you notice from March, 14 is low. Heat pumps work exceedingly well. It's very easy through all of these months for them to heat your home. They do it when it's really cold. It's harder. It's more energy, less energy efficient. But basically, you're buying a piece of equipment that can do all of the year and much of the year easily. So you're sitting back there and you say, okay, what do I want to do? And I know a lot of folks these days would like to not have gas, and that's a very viable option. The other option is to have some gas, but to really cut it way, way back. So what are the critical factors? So let's just go down the list, and then the next few slides we'll talk a little bit more about each of these items. So if you've got an all-electric system, the heat pump needs to be sized to heat your home to 10 degrees outdoor or low. The reason is that below 10 degrees, you don't use it's not a high percentage of your heating, about 10% or so. So you're not really depending, you're not using a lot of this electric strip, which is expensive to run. Remember COP of 1. If you use electric strip up to an outdoor of 20, you get about 15. That's another 15% of your annual heating bill, and that becomes expensive. In fact, that's one of the mistakes that people have made in the past. Or not mistakes, it's just not the right kind of system. Thinking I'll go all electric, I'll just have my heat pump it'll get me to 20. That's what we'll set it at, and they get a big electric bill. And that's sometimes it's the system inherently is a little bit small. Other times it's controlled. Over here on the furnace side, on the dual fuel, the heat pump can be sized to 20. And why is that? Well, 20 to 25% of your bill. It's a cost-effective strategy because gas still is an inexpensive heating fuel, even when it goes up and down around the ranges it gives. So you're still going to have a very cost-effective heating strategy. And when I say cost-effective, I'm comparing it to like just getting your old furnace and air conditioning. So the big thing now is you have a duct system in your house of a certain size, and usually on this side, if you want to heat down to 10 degrees, the duct system is going to need to be upgraded or upsized because it's not quite big enough to heat with a heat pump down that cold. And I'll talk about this more in the next one. Electric system will likely need to be upsized because you're going to have a 220 circuit for the heat pump and a 220 circuit for the supplement. And so this part of this equation, might be on the order of 5,000. The duct system is a big variable, could be quite expensive. Over here, your duct system will be adequate. You might need some small modifications. The electrical system is likely adequate because you're only 220 for that, and you'll need to maintain. But you now need to keep gas service for the next 15 years. So, so that's kind of the big trade-off going to that route. So that's really your two choices here. So let's look at the electrical. And so the electrical panel is you're going to find out what size system can my heat pump do using the existing electrical panels of service. And what you can do, people have electricians come, but I realize that if you can take a photo of your panel and document really well what all the breakers are used for, um, you could send it to your electrician, and they could remotely look at that and give you a good idea of how much amps you can add. And later on, or actually in the appendix, I have some guidance on how much amps. You can typically think of it as the heat pump might need a 40 amp 220, and then your electrical, we want to keep it lower, but it might need like a 10 amp 220 or 20. And then what's the maximum size heat pump that my duct system can support? And here's why the duct systems need to be upgraded. The heat pump, when it produces heat out of the unit, is 195 to 105 degrees warm air, which still is plenty to heat your house. You're only heating your house to 72, but a furnace produces 140 to 170 air. So it produces a lot warmer air right at the coil. So if you need so many BTUs to heat a room, you have warmer temperature, you need more airflow with the heat pump. So the ducts designed for the furnace are usually large enough to heat your home down to about 20 with a lower heat pump air temperature, because they're designed for the higher temperatures at -10. When you're building a new house and you're going with all the heat pump systems, typically the ducts, you design them bigger for the heat pump system. Bigger is like 20 to 30% bigger. That sounds like a lot, but basically it's a couple inches here and there on the main trunks and a few extra supplies in return. So here's, in terms of electric, this slide will tell you. So this is typically the size of systems for many homes. And this is the amps. So depending on what your panel, if you got a 150 amp panel, typically you can get these in. If it's 100 amp, it's going to be tricky even for just a heat pump. So if you have an existing AC unit, so the other thing now is, what size my heat pump do I need for 20 degrees, for 10 degrees? If you've got an existing AC unit, the ducts will handle that size. So the AC unit might be 2 tons or something. But the AC unit is small. Our cooling is small relative to heating. So typically you're going to be able to put on a half-ton larger heat pump, or maybe even a ton with no or little duct changes. If you don't have an AC unit, typically a heat pump size is roughly half the size of the furnace. But I'm going to show you how the contractors will size it with J. So sometimes if you want to get a little more out of things, like say you're saying, oh, my duct system works to 20, and the contractor might say, you probably should add a couple little returns or supplies. It'll make it work better. You can get it down to 15 degrees. So sometimes there's little things you can do to the duct system. But if you really need a big change to get it really cold, like working down to 10, you got to do something more. So you will hear out there manual J for sizing. And this is a little bit complicated, but it sort of gives the whole picture here. So the bottom axis is, again, outdoor temperature, -30 to 70. And this up here is the amount of heat required to heat a home. And the red line is, this manual J is a modeling program. So typically, a solid red line is the heating needs. Now, often in the field, when they get out there, the houses maybe perform a little better. So this is kind of the area uncertain. Oh, the house might not need quite as much heat. Now you've got the heat pump. So you've got a heat pump. Let's say it's a nice cold climate. That's this green here, and its capacity all the way to 0 holds, and it starts to tail off a little bit, but it goes to -13. But that's sitting in a perfect, nice factory floor. So in the field, it might not. So you've got these two things. And typically, if you're going all electric, you're going to want to size this crossover point somewhere in the 10 to 0 range where the green line and the red line will intersect. That's if you're going to have a heat pump with electrical behind it. If you're going to go with gas, it's going to be down here a little more. And so actually you can get a unit that comes across and maybe intersects right around in here. So this is what the contractors can do this model and tell you what size will be needed for each of your two options. So after you determine the size based on, ducts, you got your ducts, you've got your manual J, and then you're going to say, all right, I'm going to switch over to various nice backups. And this one, basically what you're going to want to do to make this complicated story simple is if your changeover temperature to your backup furnace is around 20, this is about, your 72, 75% your annual heating with a heat pump. And the heat pump runs most of the time and the furnace runs a little bit. If you're down here at 10 and you're all electric, you've decided basically I'm going to upgrade my electric system. I'm going to upgrade my ducts. So really 90% is the heat pump and only a little bit is the back. So let's talk about you've got a furnace and you say, well, there's two reasons you want to think about this. You're going to just replace your AC. And you say, my AC's old. Do I keep my furnace to do this? Or both things are old. So if the furnace is 17 years or older, you really need to get a whole new match system if you're going to go that way. You're going to get a new furnace and a heat pump from the same manufacturer because the controls talk to each other. All the integration is very tight. It'll work very well together. And there's two levels of heat pumps. You can get the really cold climate ones, or you can get high efficiency. They're called tier ones, which work well down to 20, and then so that's what you want to talk about. Now, if the furnace is younger than 17 years old and has an ECM fan motor, there's two kind of fan motors, ECMs and PSC. PSC is the old one. They use a lot more energy. ECM doesn't. So if it does have that, you can keep your furnace. But what you should think about is calling the same manufacturer as your existing furnace, or the contractor who represents them, because they can say with this furnace, these levels of heat pumps still can talk to it and will work well together. It doesn't help to get a heat pump that's extremely high and the communications don't work because it doesn't help as much with efficiency. If the furnace is younger than 10 years and doesn't have this motor, let's just say you got a sort of a basic one, you got a couple. The real thing to do is rather than throw that furnace out is you can upgrade these fan motors, keep your furnace. You got to talk to some contractors and get some opinions and quotes. I will say most likely you will be somewhat discouraged from doing this, but I would push a little bit because it is less money than buying a new furnace, and you've got a furnace going to last a long time. If it's 11 to 16 years and it doesn't have that, then you can discuss both options. It's just going to depend on your situation whether you should upgrade the motor or get a new furnace. There's not a real easy answer to that. So you got the contractor questions for sizing. So the one, he does all this sizing and says, I think you need this size heat pump. And you say, well, what outdoor temperature will it heat my whole house? The heat pump. Is it 20 dual fuel? Is it 10? And then there's that changeover. So when they put the system in, they'll go into controls and change the temperature. Or they might say, oh, I set it to 25 to go to the furnace. You say, well, how do I set it to 20? And you want to keep the system control simple. If it's a dual fuel, usually that changeover temperature says heat pump 1 above certain temperature, gas furnace above another. If it's electric, the heat pumps can work smarter with the electric, and there's the region where the heat pump and the electric go back and forth, and then all electric. But you want to kind of keep it simple, and it depends on the specific. And you can ask them, how's my duct system? Does it make sense to do a few little changes to maybe help them out? And a lot of times it's comfort too. Talk to them. Oh, this room's cold. This room's hot. I'm not getting good flow. So there's two heat pumps levels, cold climate. I'm running kind of slow here. I'll pick it up. And this is kind of the criteria, variable speed compressor. And then there's these high efficiency ones. Recommendation is you have a two-stage or more, not just a single stage. And this is really just for dual. And this is just some hints on how you know you're getting a good heat pump system. Ask them about these very specific things. Talk about the warranty. I often recommend getting a quote for the extended warranties. So ducts, make sure if they're old duct system, especially if they're in unconditioned spaces, they've got to be sealed and insulated really well. He's going to evaluate your ducts. He's going to measure. He's going to count supplies. They're going to count returns. They're going to measure. And they're going to say, you're constrained. This is what we can do, or this is what we can't. And sometimes you can easily add to make sense. I need to mention this. If you're upgrading, you really want to get a fresh air heat recovery ventilation system. This is for when it's super cold out or super hot. You don't open the windows or super smoky. This is a nice way. It integrates with your furnace or your air handler, and it gets fresh air in and it exchanges so you don't lose heat. And it also has filters in, so you can keep some fresh air without all the smoke. This is some stuff for outdoor. You got to get them off the ground unless you want to shovel them out. Try to keep them out of the windiest spot. Sun helps defrost. You put a snow and ice shelter over. Make sure they're drained well. Good contractors, ask them to send pictures of some installs. So contractors, all those resources that Diego described, they have some really good references about contractors. You can ask their friends. I think one thing when you have initial conversations, they're going to be enthusiastic about heat pumps. Try to figure out how to work with you on that. If they're not, then I might consider another. And one thing I just want to say, online now, like anything else, there's all these prices that are just crazy cheap and everything. And this is a very important product. You want to have it so I would say, unless there's manufacturers repped and distributors of equipment in the state, I would shy away from it. It'd be like buying cars that don't have any way to repair it. And this is the summary which you can read, and then I'll wrap it up from there. If anybody has any questions, or since we have so few, if you want to get on and ask about your specific situation, I'm sure Diego could turn on so we can have a little chat. But thank you.
Yeah, thanks so much, Dave. Yeah, we only have a few of us in here today, so if you have a question and you don't feel like typing it out, you can raise your hand and I can unmute you. Or if you have a question you want to pop in the Q&A, please let us know. But yeah, we, have a lot of resources available to you if you are considering installing a cold climate heat pump. This is a snapshot of some of the rebate incentives that are out there and available for folks who are installing qualifying cold climate heat pump systems. So High Country Conservation Center, which serves Summit County, if households make under 160% of the area median income, they can get up to $4,000 in a heat pump or heat pump water heater rebate. Over that household income limit, it's a $1,000 rebate. Core is our Energy Smart partner in the Roaring Fork Valley. Folks who make up to 150% AMI in that area can get up to 15,000 in a rebate or grant for a cold climate heat pump, and then over that 150% AMI can get up to 7,500. In for Clear, which serves Garfield County and Glenwood Springs. Anybody who's on Glenwood Springs Electric can get up to $2,000 for a heat pump. If you are income qualified, it could be up to $3,000. But please note, rebate funds have been exhausted for this year and may not be available till next year. XL customers, I believe this goes for any XL customer in any area. XL offers up to $2,200 for cold climate heat pump. That's if you are an XL electric customer. And then here at Walking Mountains, we serve the Eagle River Valley from Vail to Cerro. Folks can get up to $1,000 for a heat pump or heat pump water heater and a rebate. And then we also have an income qualified program called Reenergize Eagle County. So if you think your household might be qualified for that, please reach out to us. We have links there that you can click when we send these slides out. That'll take you to each respective website so you can learn a little bit more about everything they offer, and also email and phone numbers there if you'd like to reach out to us in person. So not quite, I'm not seeing any questions so far. Did anybody else attending have anything they wanted to ask? I'm not seeing anything. Just wanted to thank you again, David. Thanks to all of our sponsors, and thanks to everybody who attended here live today. Again, we've got lots of resources available. Depending on your utility, we can help you navigate what those rebates might look like from the utility, as well as from an Energy Smart Colorado partner. So please don't hesitate to reach out to us if you have any questions, if you're thinking about installing a system, if you want to add cooling. There might be some other measures that you can take beforehand, like insulation or air sealing in your home that can actually help improve the performance of a heat pump system down the line. So we definitely encourage you to reach out to us if you have any questions about our offerings or are thinking about installing a heat pump. Still not seeing any questions, so I think we can go ahead and wrap this up. Again, we'll follow up with the slide deck and a link to the recording. So be on the lookout for that. Feel free to pass it on to anybody you might know who might be interested or is considering installing one of these systems. But thanks again to everybody for your support and for attending today. And thank you, Dave, for a great presentation.
Thanks, Diego. Thanks, folks, for taking time out to attend.
All right. Take care, everybody.